Hello everyone, this is Dr. Hussain from rxcalculation.com. In this video, I'll review the ratio and proportion method in the easiest way possible. This is one of the most important concepts in pharmaceutical calculation. You can use this method to solve many pharmacy-related calculations. So first, I would like to discuss what a ratio is. A ratio is simply a comparison between two quantities. So it is a comparison between two quantities. So there are two types of ratios, part to part ratio and a part to whole ratio, which is the fraction. So a part to part ratio compare two separate quantities within the mixture. But a part to whole ratio compares a single part to the mixture. For example, you have mixed 667 milliliter of the 5% dextrose and 333 milliliter of the 50% dextrose to make 1000 milliliter of the 20% dextrose. So if you want the part to part ratio, we compared the amount of 5% and 50% dextrose. As you know, we have used 667 milliliter of the 5% and 333 milliliter of the 50%. So you are comparing 5% with 50% to calculate part to part ratio. We can use the same example to calculate part to whole ratio. Whole means like the mixture, and part means each single item in the mixture. We have used two different concentrations, as I said, 5% and 50%. That means you will get two different ratios. First, you need to compare 5% with the total. Then you can also compare 50% with the total. The total solution is 1000 milliliter. So the part to whole ratios are 667 milliliter over 1000 and 333 milliliter over 1000. In pharmacy, the drug concentration are usually expressed as part to whole ratio. For example, acetaminophen 160 milligram per 5 milliliter oral suspension. That means 160 milligram of the drug acetaminophen is present in total 5 milliliter of the oral suspension. Let's talk about proportion. A proportion is simply an equation that states two ratios are equal. So do you think these two ratios are equal? Let's check. If you divide the both numerator, like the top number, and the denominator, the bottom number, by the same non-zero number, the ratios, the value of the ratios remain unchanged. This is just you are simplifying the ratio. For example, if you divide 160 by 5 is 32, and if you divide 5 by 5, because you need to divide by the same number, is 1. That means you get 32 over 1 milliliter. So 160 milligram over 5 milliliter is equals to 32 milligram over 1 milliliter. That means we can use these two ratios to set up a proportion equation. When you set up a proportion, you need to make sure you put the same unit on the same side. Milligram on the top, milligram on the top. Same item on the same side. 160 milligram is the amount of drug. 32 milligram is the amount of drug. And 5 milliliter is the oral suspension. Is milliliter, milliliter. It's a suspension, suspension. So same unit on the same side, same item on the same side. This is how we set up a proportion. You cannot do 160 milligram over 5 milliliter and 1 milliliter over 32 milligram. You cannot do this. Let's read this example. Let's say a physician prescribed 10 milligram per kilogram of acetaminophen for a child who weighs 6.8 kilogram. Your job is to calculate the dose in milliliter for this patient. So first we need to calculate the single dose in milligram. You can do this type of calculation using dimension analysis. See, kilogram cancel out, so 10 times 6.8 is 68 milligram. So 68 milligram is the dose for this patient. This is the amount of drug the patient needs for each single dose. But what is the source for this drug? The suspension dosage form. Now we know the concentration, we know the strength of this oral suspension, which is 160 milligram over 5 milliliter, and the patient needs 68 milligram. So the first ratio is the concentration, and the second ratio is the dose. So 160 milligram over 5 milliliter, and the patient needs 68 milligram. We'll calculate the dose in milliliter because the patient will take the suspension dosage form. And then do the cross multiplication. X times 160 milligram equals 68 milligram times 5 milliliter. Then if you divide the both side by 160, because we want to solve X, you will get 2.1 milliliter. So the patient needs 2.1 milliliter for each single dose.